So this video is introducing the concept of experimental probability. But before that, let's start with what we've learned from last example. Okay, so here's a very simple question. So there are 200 small pigs, 250 medium-sized pigs, and 30 large pigs in a farm. If one is chosen at random from this farm, find the probability that it's a large one. So very easy. You take 30 as the number of large pigs, and this is the total number of outcomes that we wanted. Okay, so but what if in many actual scenarios, in real world examples, we don't always have the exact true number of outcomes that we wanted for each categories? So what if we don't have any information of the number of pigs in this farm for each category, and we still want to ask this question? So how do we do it? The most scientific way to approximate this probability here that we're looking for is by performing experiment, meaning that I am going to pick a pig in random from a farm, and I'm going to do that a large number of times. Say I'm going to do it 480 times, and then I'm going to record how many small pigs as a result that I've picked within this 480 times, or and also how many medium-sized pigs and how many large pigs that I've picked. Okay, and then I could sort of approximate this probability. So this is what we call the experimental probability. Okay, we make these numbers by ourselves. All right, so again, if we don't have the true numbers, the question will be reshaped into the following: a pig is chosen at random and its type is recorded before releasing back to the pig farm. Such process is repeated 480 times, and the records are as follows: 224 small, 168 medium, and 88 large. Okay, and of course, as you can imagine, if we do more than 480 times, okay, we could expect the probability will be more accurate. Okay, so say if we do it 1,000 times, 10,000 times, okay, our results will be more accurate. I also want to point to you that each time the pig is put back into the farm before we pick again. Okay, so this is very important. This is with replacement, right? Otherwise, your probability will be not accurate. Okay, and so our question will become like this: find the experimental probability that the large pig is chosen. And to do that, it's very similar. We take 88 over total number of times, that is 480. Now when you compare these two, okay, this one is just an approximation, which that's the best that we could do. Okay, or we could improve it by doing say 5,000 times, and our result should probably be as close as this true number, okay, which we don't have. And this is pretty much how we gather statistics based on experiments in the scientific world, because in reality it's usually not available for us to have the true numbers.